Welcome to the best resource online for learning GraphQL with React. My name is Stephen and I'm a web engineer with 12 years of programming experience. I authored this course to share the knowledge I've gained in that time with you. The number one goal of this course is to make sure that you are not wasting any more time copy-pasting code into your code editor. We are going to explore every syntax step by step to make sure you understand exactly what we're building. I built this course to make sure that you don't have to spend any more time on confusing, out-of-date, or incomplete tutorials again. In this course, you'll master the basics of using a GraphQL server with a React frontend. GraphQL is the biggest new technology in the web development world and boasts a huge improvement to the performance of your application, along with helping your development speed as well. Learning how GraphQL works is not just about understanding the syntax of it. We will also have deep discussions about how GraphQL works internally so that you can become a master in learning how to create GraphQL servers. After getting familiar with GraphQL, we will tackle the front end of our application with the Apollo client. We will use GraphQL and the Apollo client to build a fully functional application complete with user authentication. I place extra emphasis on building projects in a scalable, production-ready way. No shortcuts at all, we only do things the right way. Every topic includes discussions about why and where we would use each of these examples. The entire course is hosted on udemy.com with easy-to-follow videos and an entire Git repository with all the course's code. Sign up today. Be the cutting-edge engineer who gets to teach others the latest in web technology. Sign up today and build the GraphQL apps you've always.
Hello and welcome. My name is Stephen Grider, and I am here to teach you everything that I know about GraphQL and React. Before we get started with any code, I want to cover a couple of frequently asked questions about this course and give you a better idea of how it's structured. First, I want to tell you a little bit more about what we're going to be covering in the coming sections. We're first going to be discussing why GraphQL exists. GraphQL has the interesting distinction of being a technology where it's very important to understand what problem it intends to solve. Once you understand what GraphQL attempts to solve, understanding it starts to become a lot easier because you're able to frame all the different challenges of the framework into understanding why we're using it in the first place. After we talk a little bit about why GraphQL exists, we'll talk a little bit about exactly what it is. So, what is GraphQL? If it is meant to solve some existing problems, how is it going to solve it? What does it really do for us? Finally, we'll talk about how we use GraphQL. So how do we make use of GraphQL on our backend applications, and how do we actually wire that up to our React front end? So this last step right here, of course, going to be the very longest section of the course, and will be the bulk of everything that we cover. Now, before we get started with anything else, just one last quick slide, a couple of frequently asked questions and answers that I get throughout all of my different courses. First, I use Balsamiq mockups to create all the different diagrams that you'll be looking at inside this course. I've used many different types of diagram tools. I found Balsamiq has the best mix of being easy to use and quick to put diagrams together, but the diagrams that are generated also look really nice, which is a nice little benefit. Next, I use Atom for my code editor. You're free to use absolutely any code editor that you like. There's absolutely no requirement to use Atom. You can use Sublime, WebStorm, TextEdit, anything you want. It's up to you. Finally, for my terminal, I make use of iTerm with Z Shell. So if you get the same looking command prompt that I do, you can grab iTerm and Z Shell and you'll get something right out of the box that looks pretty much identical to what I use. Okay, so that's it with frequently asked questions. Let's get started with the real interest.
We've had a chance to discuss some RESTful routing now, and we've made a case of where it seems to fall just a little bit short. Remember, there are 3 different areas where RESTful routing seems to kind of come up with some issues. First, deciding on a URL schema gets tough when we start to have heavily nested relationships. Second, when fetching heavily nested data, can easily run into situations where we make too many HTTP requests to get the data that we need. Third, we are vulnerable to overfetching data, where we fetch an entire company when maybe we really only needed the name property off that company. Keep in mind that with each of these issues, there are definitely problems that can be solved, but coming up with solutions like this kind of takes a lot of engineering time. So we always want to be aware of how much time we're spending on solving any given problem. And this is where GraphQL comes in and allows us to solve these issues in a very timely fashion. So in this section, I want to spend a little bit of time to tell you exactly what GraphQL does to solve each of these inherent pieces of confusion around RESTful routing. Let's think back to our diagram of our current user who is trying to fetch details about their friends. This user had some friends, and each friend had a company and a position record associated with it. Right now, we're looking at this diagram in a sort of tree fashion, where we start with the current user, and then we look at the users they are associated with, and we look at the associated companies and positions with them. So everything is focused around this current user, or it's all from this current user's viewpoint. Now I'm going to change up this diagram in a big way. And rather than looking at everything from the viewpoint of this single user, I want to imagine all of the data in this application, all the data in this imaginary database, including all the users, all the positions, and all the companies. So the diagram I'm going to swap to is going to look just a little bit crazy, but really it is conveying very similar information as what we're seeing right now. Okay, let's look at it. Okay, this diagram right here shows a graph of all the relations in our application. When I say graph, I'm not talking about the type of chart you find in an Excel spreadsheet or your favorite spreadsheet application. A graph is a data structure that contains nodes, which are symbolized by all the different rectangles in here, and relations between each of these nodes, which we refer to as edges. So this is the graph that GraphQL is referring to. And understanding how our information fits into a graph data structure like this is key to understanding how GraphQL works. One thing that I want to mention about this graph structure right here is that I'm not saying that we're going to change how our data is being stored in a database or anything like that. We can still use MongoDB, Postgres, MySQL, whatever we want to use to store data. We're just looking at this diagram to kind of visualize how all of our data is connected together via all the different relations. Okay, now that our data is organized into a graph, I'm going to take all my different users and assign some IDs to them. Once we've got all of our data in this graph structure, what do we do with it? How do we kind of query about the information that's contained in here? Well, once we have organized our data into a graph, we can query it using GraphQL. So let's see an example of what this might look like. Okay, we're going to kind of picture a GraphQL query running along this graph right here. Let's imagine that we want to start with user 23 right here. I want to find all of their friends or other users in the application. And then I want to find all the companies that those users work at. Okay, so let's visualize how we would form a query or ask a question like that to GraphQL. Well, first, we would tell GraphQL that we wanted to go find the user with ID 23. Next, we would tell GraphQL to go and find all the friends associated with with user 23. Finally, we would tell GraphQL to find the company associated with all of those friends and get maybe the name property off of it or something like that. So in summary, we started by telling GraphQL to go and look at a very particular record, like this record right here, and then crawl through all the records associated with it. To instruct instruct GraphQL on how to do this in practice, we write and execute what is called a query. So let's look at a query that would do something very similar to what we just saw, like start with a particular user and then go find the associated friends, companies, names. So the query that we're about to write, we're just going to do right here on the side of this diagram, is going to look really familiar once we start working with GraphQL. It's going to look like JavaScript right now. It might look little bit weird, but trust me, we're going to get really familiar with queries with GraphQL. Okay. So this is going to be the query that we would write to go from user 23 all the way up to the company up here. First, we start off by telling GraphQL that we want to make a query. So I would say query and then open curly braces. I would say I want to find a user with ID of 23. That will tell GraphQL to look at this user right here. Next, we'll tell GraphQL that we want to find all the users who are friends of the initial user. So to crawl along to the next layer, or the next set of relations right here, we add in friends, like so. Now you might be curious why I'm saying friends right here and not like users again. Well, we'll talk about that, but really we could consider them to be just users as well. Either way, we're essentially telling GraphQL, kind of walk this graph a little bit, like walk to the next relation, walk to the next node. And now the last step. We go from friends to finding all of the companies associated with those friends. So I would say company, and then because I want the name property off of every single company, I would write out name, like so. Okay, so this is the first query that we're going to look at. We're going to implement this ourselves inside of a GraphQL application. I don't expect you to understand the syntax of queries at all, not whatsoever. I just want to give you an example of how we take a query and we can imagine that it is walking along a graph for every single statement in the query that we have. Okay. Let's take a quick break because this has been a lot of crazy stuff. Let's take a quick break and then start working on a practical example of this in the next. Let's get to work on our resolve function. So from this function, we want to return a very particular user, the user with some given ID. For this first iteration through our app, we're going to skip the use of any fancy database or anything like that, and instead we're going to work with some hard-coded data. So we're going to hard code in a list of users and then walk through that list of users and return one of the users from this resolve function right here. So I'm going to go up to the top of the schema file and we'll make a hard coded list of users. So we'll say const users, that will be an array, and let's just add in 2 quick users in here. We'll say that every user has an ID. I'll give my first one ID of 23, a first name of Bill, and an age of 20. And we'll also make another user with an ID of 47, a first name of Samantha, and an age of 21. Cool. I'm also going to require Lodash while we're up here. So I'll say const underscore equals require Lodash. Lodash is a helper library. It just helps us walk through collections of data and work through collections of data. For us in particular, we're going to use it to walk through the list of users and find the user with a very particular ID. So just a little helper library for us to use. So now let's go back down to our resolve function. Remember, the root query right here is what points us to a very particular record in our graph of all the different data records that we have. We've said that the root query has the expectation of receiving an ID as an argument. When the ID gets passed in, it will be available on this args object right here. So to find the user with the given ID inside of that users array that we just created, we can put out return underscore dot find users and then an object with ID and args.id like so. If you're not familiar with Lodash, no problem. We are walking through our list of users. Okay, so go through all the users and find and return the first user who has an ID equal to args.id. And remember, this args.id right here will be provided to the query when the query is made. Whew. So that's our resolve function for right now. We're going to come back and improve it, make it a little bit more robust, make sure that we're not using a hard code list of data, which will be much more interesting. But for right now, we want to just kind of get something up on the screen. So at this point in time, if I was in your shoes learning GraphQL for the first time, at this point I'd probably be saying, what the heck is this root query doing? What is this args thing? what is this resolve thing? This is crazy. This is madness. Yes, I completely agree. Well, maybe you think it's totally normal. I don't know. The first time I looked at all this, I said, yeah, this is pretty heavy duty stuff. And it really is. It is heavy duty stuff. So I think right now, let's beeline getting our example to work in the browser. I think that once we play around with this in the browser, we're going to have a much more reasonable idea of what is going on. Okay. So we're going to take the two types that we made, our user type and our root query right here. We're going to merge them together into a GraphQL schema object. We're going to hand that back to the GraphQL middleware inside of our server.js file. Okay, so one last little step here, and then we'll be able to test this out in our browser. The first thing we're going to do is import a helper from the GraphQL library called GraphQL schema. GraphQL schema takes in a root query and returns a GraphQL schema instance. So we'll go back down to the bottom of this file. And I'll say new GraphQL schema. That is the helper we just imported. I'll pass to it an object. Remember, the root query is what we just defined right here. So here's the root query. Now I want to export the schema that we just created from schema and make it available to other parts of my application. So I'm going to assign the result of this to mod exports, like so. Okay, so last import this into our server.js file. So over in server.js, I got the line in here already. Let's just go through adding it. Schema is require from the schema folder, from the schema file, and then we'll pass that schema as an option into our middleware. So we'll say schema with a comma like so. Note that we're going to use yes here because our key and our value has the same name. We can pass in just schema by itself, and that will be automatically expanded to be schema like so. Okay, so one last step, we need to restart as we made some changes to our code base. So I'm going to go back over to control server, and we'll start it back up with node server.js. And cool, I get listening right here. If you have any typos in your code at this point in time, you'll see some error message pop up in here. I can almost guarantee you that if you see an error message at this, can almost guarantee you they've probably got a mistake with capitalization somewhere. So you'll want to double check to make sure you've got good capitalization everywhere. So now we can change back over to our browser. I let localhost /GraphQL to refresh the page. And ta-da, now I get my graphical interface pop up on the screen. Want. So come back and investigate a little bit more graphical thing is in the next section. We've now got our users hooked up to our list of companies, and we can ask for details about each company that a user is associated with. So if we look at our query over here, yep, we can access a user, we can ask for their company, and we can get the name of that company, like so. But we do not yet have the ability to ask for just a company by itself. So I can't do something like, hey, you know what, just give me the company with an ID of 1 and tell me the name. We don't have a field on the root query type that allows us to do this yet. So if we think back to the diagram that we were looking at, this one right here, remember our root query only allows us to go to a user. We don't have the ability to go directly to a company just yet. We can only access the company by first going to the user and then over to the company. So in this section, I want to work on adding the ability to go from a root query over to our company directly without having to worry about any users in between. After we do that, we'll be able to make a query that looks just like this, where we can say, hey, go find a company and tell me a little bit about that company. You know, go find the one with ID 1, tell me their name, tell me their description, and so on. So let's open up our schema file. We're going to find our root query type inside of there. Here's my schema file. I've got my root query type right here. And we're going to add on another field to our root query type that we're going to call company. And it's going to allow us to query directly for a company. So let's get to it. In the fields object, as a sibling to user, so this is a sibling to user, we'll say company. The type will be a company type because that's what this field is going to return. It's going to return a instance of a company. And then the other arguments that we're going to place on here, or the other properties, are going to look nearly identical to the user. So we're also add on the args object because we want to be able to ask for a company via a very particular ID. And also define the resolve function that will actually go out, find the particular company, and return it. So we could place our args with an ID and type of GraphQL string, like so. Remember, this args object right here define or tell our schema that whenever someone tries to access this field, we expect them to be providing this ID argument, and the ID should be provided as a string. Then we can do the resolve function. And again, it's going to look awfully similar to the request that we just made to get a particular user. We'll make a network request over to HTTP localhost 3000/companies slash, and then we'll use string interpolation or template strings and say args.id, like so. Because I used a template string in here, a little bit of ES6, do make sure that you're using backticks instead of single quotes here. Very important. And then again, we'll get a little bit of compatibility between Axios and GraphQL just to make sure that we only return the data that comes back from the request and not the entire response object. All right, let's give this a shot. I'm going to change back over to my graphical. You'll notice that I still have an error here. Remember, graphical does not automatically refresh our schema. We have to actually refresh it manually. And now it should be a lot more obvious. Graphical gets the new schema. It says, okay, I understand that I can fetch a company. It looks like you gave me the correct arguments. Okay, I'm happy. Let's run this query. Again, if you get this unknown operation null, you can just delete and retype name. Just a little bug around graphical. And when I put the name in and run the query, now I'm returning Apple. Fantastic. We can also look for the description. And of course, we want to get the ID in the response as well. There we go. Perfect. So this has added the idea of a company to our schema. If you had any issue getting this thing to show up, always remember you should check your terminal out and make sure that you don't have any errors or any typos. If you have any typos, they'll always show up in here and let you know, hey, you got a typo on XYZ line. Okay, this is great. Let's go back and continue in the next section, and we're going to work on linking together companies and users. In the last section, we started up a separate server that serves raw JSON data. The idea here was to get some experience where our GraphQL application pulls in data from an outside server rather than using the static data that we are currently using, which is the hard-coded list of users inside of our schema file. The two things I want to point out to you, just to be really clear about the JSON server, is that if we go to localhost :3000/users, we get a list of all our users. And then if we go to /23, that will give me a user with ID of 23. I could also go to 40, and there's my user with ID 40. Do note as well that this is running on a completely separate port from our GraphQL instance or from our graphical instance. The other one is running on localhost 4000. The server we just started up is localhost 3000. So two completely separate, disconnected servers, completely separate. All right, with all this stuff in mind, let's open our code editor and check out our schema file. So here's schema.js. In our schema file, I'm going to scroll down to our root query towards the bottom. Inside of here, we are still making use of Lodash to search through the local list of users we have. Remember the purpose of resolve. It must return the data that represents a user object. Right now, it is returning the user directly in a very synchronous fashion. So when resolve gets called, boom, we instantly return a user. The resolve function, however, can also work by returning a promise. So it can work in asynchronous fashion. If we return a promise from the resolve function, GraphQL will automatically detect that we've returned a promise, wait for the promise to resolve, and then once it does, grab the data that it resolved with and send a response back to the user. So in practice, once we make a request or a query from our graphical interface, it's going to go to GraphQL. GraphQL is going to reach out to our JSON server and say, hey, I'm looking for user 23. And that is, of course, an asynchronous request. It is an HTTP request to go out and reach to this other server. The JSON server will then respond and say, hey, here you go, here's user 23. GraphQL is going to wait for the request to resolve, and then it's going to get the user back and send it back to the response to the graphical client. So that's what we're going to do inside of this resolve function. Nearly all data fetching that we're ever going to do inside of a Node application is asynchronous in nature. So we nearly always end up having to return a promise from this resolve function right here. Okay, so I think we've got a plan to move forward on. We need to make an HTTP request inside of this resolve function right here and return the promise that it generates. To do so, we can either use the native fetch function, or we can use the library Axios. And remember, fetch and Axios are both used for making HTTP requests. If you've taken any of my courses before, you'll know that I'm a huge fan of Axios. I am not a fan of fetch, so we're going to go with Axios. Let's get to it. Axios is a third-party library, so we are going to flip back over to our server and ensure that we install it as a dependency. So inside of my server directory, I'll run npm install -- save Axios like so. And it's a really small library, so it should only take a second to install. There we go. Now back inside of my schema file, I'm going to import Axios at the top. We don't need Lodash anymore because we're not going to be going through that static list of users. So I'm going to replace the Lodash import with a require statement for Axios instead. We're not going to need the static list of users anymore, so I'm going to delete the static list of users. That can go as well. And go on down to the resolve function. I'm going to take out the existing statement that's in there, and we're going to replace this with a request over to our JSON server. So inside of here, we'll say return axios.get, and then we want to make a request over to localhost 3000 /users/ID, or the ID of the record we're trying to find. To do so, we're going to use a ES6 template string. So put a backtick down, HTTP localhost : 4000, or excuse me, 3000. Let's make sure we get that right. /users/ $ curly braces args.id, like so. Again, this is an ES6 template string, so do make sure that you have backticks right here on either side. And we are making reference to args.id. Remember, the ID is coming in from the query when the query is made. All right, this is looking pretty good right here. We make the request and then we return it. So Axios, or excuse me, GraphQL is going to wait for the promise that is generated by this request to resolve. Once it resolves, it's going to take the data and send it back on down as a response to the query. Now there is one little gotcha in here, okay? One little gotcha. And this is kind of an oddity of Axios working with GraphQL. When Axios's promise resolves, so if we put on like a .then, and we take the response and we console log the response like so, we get back something that looks like this: data first name of Bill. So the response object that Axios returns has the actual response data nested on this data property right here. It is nested on it, and that is just how Axios chooses to respond from HTTP requests. It nests the data on this data property. Now the bad news is that GraphQL does not know that. It does not know that the data is nested on this .data property. So just to make Axios and GraphQL work together, we're going to do just a little bit of finagling with the response before it goes on to GraphQL. So we're going to say resp.data like so. So what this does is it says make the request, and then before anything else happens with the promise, like before any other function gets tacked on to this promise to be resolved, take the response, return only response.data. So anyone else who chains on this promise, like with another .then, they would only see the data that came back from the response. So in other words, we're just paring down the response object that comes back from Axios. I know this probably seems a little confusing, a little bit arbitrary, it's a little bit painful. Yes, I agree, but it's what we have to do to make Axios work nicely with GraphQL. In the future, we will wrap Axios with a nice little request handler, and so we won't have to deal with this all the time, but we'll take care of that in the future. Okay, I think we're ready for a test now. So I'm going to go back over to my terminal. I'm going to start my server back up with node server.js. I get the listening message, which was good, and it appears that my JSON server is still running as well. So everything is looking pretty good at this point in time. Let's go back over to graphical. So I'm on localhost :4000/GraphQL, and we'll make the same query for user 23. We run it and we get back Bill. Okay, that's great. Let's look for user 40. Remember, for me, I had made user 40 inside of that db.json file. So inside of db.json, here's user with ID 40. If you used any different IDs, you'll see a different ID here instead, and you'll want to use a different ID as the argument to the query. So look for user with ID 40. Again, yep, it looks great. We can check out our terminal, and inside of here, you'll also notice that we see the request logs from our GraphQL server reaching out to the separate JSON server to fetch these independent records. Okay, so not too bad, not too bad. I really like how this is going. We've split off our resolve function to reach out for some data from some third-party service. The key thing to keep in mind about resolve right here is that because it can handle a promise, we can really fetch data from anywhere you can possibly imagine. This can be a third-party server. This could be reading a file off the hard drive. It can be a database, anything we want to do. Resolve is really our playground for just fetching any piece of data in any fashion that we can possibly imagine. Okay, let's move on to the next section and start putting a bit more logic